Warm welcome to everybody. We are from EC Department of Welltech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. First and foremost, we thank our college management, principal sir, head of department, and our guide Prabhu sir, project coordinator Mohammad Abbas sir. We have done a final year project under the title iFundus disease segmentation and classification using Linux and unit architecture. Our team consists of Lakshita, Sivaranjani, and Sri Vishali Durga. In this video, let's see the execution of our project in detail. Before dividing into the details, let me explain why this project is important. Millions of people worldwide suffer from eye diseases like diabetic retinopathy, glaucoma, and cataract. These diseases often show no symptoms in the early stages, making early detection crucial. If these conditions are not diagnosed and treated on time, they can cause progressive vision loss or even complete blindness. According to medical research, diabetic retinopathy alone affects over 100 billion people globally, and glaucoma is known as the silent thief of sight because people often realize it too late. Traditional diagnostic methods involve manual inspection by ophthalmologists, which can be time consuming, subjective, and sometimes inaccurate, especially when dealing with large volumes of patients. Many areas, especially in rural regions, lack access to specialized eye care, making AI based automated diagnosis a potential game changer, improving healthcare accessibility. Now, let's see how does our project help. Our system takes an iFundus image as input and analyzes it using deep learning models to detect diseases early. It automatically classifies the disease and also segments the affected regions, allowing doctors to visually understand the problem. Instead of relying solely on manual interpretation, our system provides AI powered insights within seconds, reducing the time required for diagnosis. We have developed a web based application, which means the system can be accessed from anywhere, making it more convenient for doctors, researchers, and even telemedicine services. This approach ensures faster, more reliable, and scalable eye disease detection, ultimately improving the patient outcomes.
Now, let's go step by step to understand what happens when a user uploads an image. The first step is image upload. The user selects an iFundus image and uploads it through the web interface. The web application, built using the Django, receives and processes the uploaded image. The next step is pre processing. The system enhances the image by removing noise and adjusting the contrast for better clarity. It also resizes the image to match the required input dimension for the models. To develop this system, we have used a combination of deep learning models, programming frameworks, and web development tools. Let's take a closer look at each technology and its role in our project. A project relies on two deep learning models, UNet for segmentation and Linet for classification. The first model is UNet. UNet is a fully convolutional neural network designed for image segmentation. It consists of an encoder decoder architecture where the encoder extracts important features from the input image and the decoder reconstructs the image while highlighting disease affected areas. UNet provides a segmented output which helps in visualizing the affected region, making diagnosis easier for doctors. It achieved 94.4% accuracy, making it highly effective for medical image segmentation. The second model is LINET. LINET is a convolutional neural network used for image classification. It processes the fundus image through multiple layers of convolution, pooling, and fully connected layers to detect patterns. The final layer predicts if the image belongs to a disease category like diabetic retinopathy or glaucoma. Linet is efficient for image-based classification tasks and provides an accuracy of 89.6% in our project. For building and training our models, we used two of the most powerful deep learning frameworks, TensorFlow and Keras. TensorFlow is an open source deep learning framework developed by Google. It allows us to train, optimize, and deploy machine learning models efficiently. We used TensorFlow for handling complex numerical computations required for CNN training. The next framework is Keras. Keras is a high level API built on top of TensorFlow, which makes it easier to build and train deep learning models. It provides simple functions to define layers, activation functions, and loss optimizers. In our project, Keras helped in defining the architecture of Linet and Unet quickly and efficiently. To make our system accessible, we built a web-based interface using the Django framework. For front-end development, we have used HTML, CSS, and JavaScript. HTML is used to create the structure of the web pages. CSS is used to design and style the interface for a professional and user-friendly experience. JavaScript adds interactive elements like real-time updates and result displays. For database, we used SQL. It manages the database where patient data and previous predictions can be stored securely. For backend development, we have used Django. Django is a Python-based web framework used to build secure and scalable application. It connects the deep learning models with the user interface by handling user inputs and processing the images. With this technology stack, our system is not just powerful but also user friendly, making it easy for doctors to upload images and get results instantly. For model development, we used two key tools, Jupyter Notebook and Anaconda. The first tool is Jupyter Notebook, an interactive Python environment used for writing, testing, and debugging deep learning models. It allows easy visualization for training accuracy, loss graphs, and model predictions. We used Jupyter to train and test Linet and Unet, ensuring their performance before deployment. The second tool is Anaconda. Anaconda is a package and environment manager used for handling dependencies and running Python programs smoothly. It helps in managing different libraries like TensorFlow, Keras, NumPy, and OpenCV, which are essential for deep learning. It ensures that all software components work together without compatibility issues. By combining these advanced technologies, our system achieves high accuracy, fast processing, and an easy to use interface.
Let's begin the step-by-step demonstration of how our system works. To run our project, we need to set up the environment. First, I open Anaconda Navigator. Anaconda Navigator is a tool that helps manage different Python environments and dependencies. Here, I switch from the base environment to N, which contains the necessary libraries and dependencies for our project. Once the environment is set, I launch two essential tools, which are Jupyter Notebook and Visual Studio Code. Jupyter Notebook is used for testing, running, and modifying our deep learning models. Visual Studio Code is used for running and deploying our web-based application. After launching Jupyter Notebook, I navigate to the music folder where our final coding files are stored. This folder contains two major models that are Linet model and Unet model. Unet model is responsible for classifying the type of eye disease, and Unet model highlights the affected region in the eye fundus images. Now let's move to Visual Studio Code to deploy the web application. Click on File, then select New Folder and select Download and select the file coding folder. Then select Deploy folder. This deploy folder containing the entire project structure. I select this folder to load into Visual Studio Code. Once the project folder is opened, I go to the terminal bar and click on New Terminal. In the bottom, I select Command Prompt and then execute the command, which is python manage.py run server. This command starts the Django web server, and after a few seconds a link appears. I click on the provided link, which redirects me to our project homepage. I log into the system using a registered account. After logging in, I upload an iFundus image. The system processes the image and provides two outputs. One is classification output and the other is segmentation output.
Now, let me tell you the advantage of our project. This system is designed to identify and classify eye diseases like glaucoma, diabetic retinopathy, cataract, and normal eye with high accuracy. It doesn't just detect the disease but also highlights the exact affected areas in the eye, making it easier for doctors to pinpoint the problem and make accurate diagnosis. One of the biggest strengths of our system is its ability to learn from a large data set. Since it has been trained with a vast collection of eye images, it ensures reliable results, improving the accuracy of disease detection. With more data, the system keeps getting better at recognizing the patterns and differentiating between healthy and diseased eyes. Another major advantage is the speed at which it works. During an eye examination, the system provides quick predictions, allowing doctors to diagnose patients faster. Instead of manually analyzing every image, they can focus on critical cases and provide timely treatment. This not only saves time but also helps in early detection, which is crucial for preventing a severe vision loss. Our system is a valuable tool for eye disease detection. It improves accuracy, speeds up diagnosis, and assists doctors in making better clinical decisions. By integrating deep learning, we are making a healthcare smarter and more efficient. This results graph shows linear and unit accuracy. In linear graph, it shows how well the model is learning. At the start, the accuracy was low, about 31%, but as it trained more, up to 50 rounds, the accuracy kept improving and reached around 89 to 90%. This means the model got better at its task as it learned. In unit graph, it shows how our model is learning. The blue line is how well it works on the data it has seen, and it gets better over time. We thank our respected guide, Mr. Prabhu, and esteemed project coordinator, Mr. Muhammad Abbas, for their guidance and support to complete this project. Thank you.